In this video, we're going to look at sections 2.5, 2.6, and 2.7. So this section is ordering integers. So this is the first time we introduce inequality notation. In Unit 1, we just have them say in words 2 is less than or is greater than the other number. Okay. So notice in the beginning here, we want them to be able to interpret a less than sign as also equivalently a greater than sign, meaning 2 is less than 5 is equivalent to 5 is greater than 2. So even though we typically read this from left to right, and we think of this as a less than sign, we want them to be able to identify the direction of the inequality symbol and be able to interpret it in either way. So in general, we'll have them do this in both ways. Okay. So you're probably familiar with some of the issues students have with ordering integers. Again, they confuse magnitude with the sign of the number. So if they had -5 and 3, they might say -5 is greater than 3 because 5 is bigger than 3. Okay. Also, we want to focus on using less than and greater than. And avoid the words smaller and bigger. So smaller and bigger or smaller and larger typically refer to magnitude, where less than and greater than, so smaller would be closer to 0 on either side, bigger would be further away, whereas less than and greater than refer to the relative position of the two numbers on the number line. So notice we have them compare a positive and a negative. We have them compare two negatives and write the associated inequalities. Okay. You'll notice in Math AS we have them answer this to make connections between the different types of phrases we use. We have them write it as a less than statement, a greater than statement, and an equality statement, and we also make them state which number is further to the right or left and that meaning, all in an effort to get them to connect all of these ideas and phrases that we use. Okay, now here is the chip model. So we'll be using the chip model a lot in this section, especially with operations. And here's the idea. So you can see we have these positive chips and we have negative chips, and this is a discrete model, meaning that each one of them is separate as opposed to a continuous model like a number line. Okay, so the sign on the chip determines whether it's positive or negative. So if you use these in your classroom, they're typically sold as yellow. There's one side of the chip is yellow, one side is red. The yellow refers to the positive, the red refers to the negative. So we don't use that here because it's printed in black and white, so that wouldn't show if they had this printed. So we use these plus and minus symbols. So here's the idea. You start off, this is 3, great, this is -4, okay? And then we want them to start to associate chips of different colors as being equivalent to some simplified number. Okay, so we're not even really thinking of addition here. We want them to be able to look at this and see, well, a positive chip and a negative chip cancel each other out. So there are 3 negative chips, so that would cancel out 3 positives. So this is another way of writing the number +2. Okay. Similarly here, 1 positive and 1 negative would cancel. So these two are actually equivalent. This is the simplest version. This will be our goal when we're adding or subtracting, is to get our numbers to simplify to just one color or one type of chip. Okay, but this is equivalent to -4 as well. Okay, so again, still thinking about integers as numbers. Now, this is a biggie, language and notation of integers, and as you probably know, this is what confuses them the most. Okay, and basically because we talk about the plus symbol for a long time and it means addition, Now it also means a positive chip, but half the time when we have a positive number, we don't use the plus sign. So it can all be very confusing to students. Similarly, this symbol, we used to use it for subtraction. Now it can also mean a negative number or the opposite of a number. Okay, so we're asking them to only use the word minus when we mean subtraction and use the word negative when we're referring to the sign of the number. And sometimes this can be challenging for teachers too. I've used both versions of them, okay, saying here -6 instead of -6, but I had an understanding already of what this number meant. I knew we weren't subtracting 6. This was -6, okay. So drawing their attention to this idea will help them, especially when we get to problems like this, where they say, well, is this minus -4, or do I subtract 4 twice, or is this 3 times -4? They start to get confused about what's an operation and what's a sign. So you want to draw their attention to this first. Okay. So here we'd say -6. In general, -6 isn't wrong, but in all of the videos in general, we're going to say if there's more than one sign in front of it, we use the opposite for all of them except the negative within the parentheses. So here we'd say the opposite of -6, -3 plus 2, 3 minus -4. Okay, and now here we are adding integers with the chip model. Okay, so basically these are grouped in a very intentional way. Notice that the numbers are all the same, or the absolute values of the numbers are the same. We just vary all the signs to all the different combinations. So let's just look at these real quick. And again, I'm going to do these quick, and if you want to look at the videos, you can get a more thorough, longer justification. But sure, so we had 2 positives, 2 negatives. Oh, well, that's all sorts of bad. Let me fix that. -5 plus -3. Okay. Also note in Math AS, we have them type in expressions by hand such as these. If they're ever going to type in a negative number, that's in an expression. So if they just had an answer of -7, they don't need parentheses. But if they needed to type this as an answer, they need to put parentheses around the negatives. And that's basically due to Math AS. If a plus and a minus are next to each other, it does the plus minus like from the quadratic formula, and it doesn't understand it. And then we also decided putting negative numbers in parentheses really makes them focus in on this being a single quantity and the negative sign belonging to the 5. Okay. So I'm just going to use plus and minuses. If we had 5 and 3, 1, 2, 3, 4, 5, 1, 2, 3. Okay, and then we think of the operation of addition, or one way to think of it is the combining of 2 sets. So we had 2 sets, we bring them together as one set, and there are a total of 8 positive chips, or 8. Similarly, this is the same idea. We have 5 negative chips, 3 negative chips. All together, we have 8 negative chips. Okay, so this will help them to see with both of these are together because it's the idea of accumulation. There's no positive and negative chips canceling out here, and it'll help them to see the connection between adding 2 positives and 2 negatives. Here we have 5 negatives and 3 positives. Okay, and again, they should start to be able to look at this as like we looked at number in the other representations. Okay, we're going to think of these as canceling out, and this is equivalent to, even with all of these chips here, it's equivalent to -2. And if we had +5 and -3, 3 cancel out again, but in this case the 2 chips that are remaining are positive. Okay, so here they'll begin to see these patterns. Okay, notice this is the sum of the absolute values of the number. The sign depends on the original numbers. This is the difference. This will drive them crazy because they're adding numbers, but they end up subtracting the numbers. So if you can show them this idea about combining and seeing what cancels, and then showing them in comparison to each other, it will start to make sense why they're subtracting, but they'll still be able to see it as an addition problem because we're combining the two sets together. Okay, so they take the difference of the two numbers. The number with the larger absolute value, you take the sign, its original sign, before you take the absolute value. That's a mouthful. It's confusing to them. If they try to follow those steps, they usually get confused, but if they could imagine this idea, they do better. And here we have a quick summary of the addition of integers, which I don't like at all. We do want to summarize this for them, and it's the general idea that we can come up with here. But we want them to really come up with these ideas on their own. If they had to write these on their own, it would have a lot more meaning than just reading them. It's good for them to be able to follow the description of a procedure, but them being able to visualize the chips is really what's going to help them be successful. Getting these rules right, they start to confuse them with all the other different operations as well. And we also do adding integers on the number line. So let's look at this real quick. Oh, I should have kept these here. 5 plus 3. I think I did keep it the same. -5 plus -3. That is the second time I've done that. 5 plus -3 and -5 plus +3. Okay. So again, here they're going to make connections. We start at 0, we go to +5, or they can start at +5 and then go 3 more in the positive direction, okay, because they're combining and they get to +8. So they could see this distance accumulating. In the negative, it's the same idea. There's two negatives. They go -5, another 3 in the negative direction. That takes them to -8. And then here, if we have 5 plus -3, okay, we can think of either going to 5 or starting at 5, and then we want to add on -3. Well, since -3 would be 3 in this direction, we start from here and move 3 to the left, which is 2. And again, these pictures help them see the symmetry and the connections. Start at -5, then we go 3 in the positive direction. That's -2. Okay, so notice this is a reflection of this one. This is a reflection of this one. Okay, this would be +3 from here. Okay, so that's the gist for adding integers, and we'll look at subtracting in the next video.